Hello everybody. Today I wanted to show you something rather neat, and for some reason it's discontinued, which could have had something to do a bit with the price. And this is a Duracell branded, because who knows if it was their own product or they just slapped their name on it, power inverter. Not just any normal power inverter. That's the input in the back there. And I'm not in my usual place here. And there's a 120 volt outlet, 2 USB ports. And what makes this one special is you don't have to hook it up to anything. It has got lithium batteries inside. It can be powered a few different ways off the internal lithium battery. Or you can hook it up to, there's an adapter where you can plug it into a 12 volt socket on a car. And then in that case, it would recharge the batteries inside and also be able to power the inverter. Or you can just use the AC adapter to charge it. I have long since lost the car adapter. I don't use it. I haven't used this at all in like the last probably 5 years, just because it's worn out. I've had this since '07, and I got it at Northern Tool and Equipment, and it was a closeout. It looked like someone actually had returned it. All the packages were open. They had 3 of them. I should have bought more, actually. And this cost me about 20 bucks. Original price was over 100. Mind you, again, that was around '07. So inverters were a little more expensive back then than they are in 2019. Either way, I used the living crap out of this. This was enough to power my netbook for almost 2 days. You can look at some of the specs on the back here. And I'll zoom in. There we go. Focus. So we have input 12 volts DC at an 8 amp max. So if you were charging this off of the car, the most it'll draw would be 8 amps. And that's for charging, or charging rate would be considerably lower, but inverter power would be high, would be what would be using up that 8 amp. Battery type, 14.1 volt DC, 4 amp hour lithium ion. So it's got either most likely 18650 cells in there, maybe pouch cells. But it's 11.1 volts, so not quite 12, which is what like a car battery is. But since this is built from the ground up, they can design the circuitry in there to work at whatever voltages they want. But that's 11.1 volts nominal. That would tell me they're using whatever type of battery, the lithium batteries in there, they're using 3 cells. So a lithium cell at this would be 11.1 volts would be nominal, whereas fully charged 3 cells would be 4.2 fully charged, which would equal 4, 8, 12.6 fully charged. Likewise, at dead, that would be approximately 369 volts dead. 9V dead. And I realized I am writing, and you guys can't see what I'm writing, but it doesn't really matter since I guess it doesn't show up anyways. So, back to this. Focus. Chris, focus, pay attention. AC output, 120 volts AC, 60 hertz. So, the outlets on here is supposed to provide 120 volts at 60 hertz. Output power continuous. Now there's 2 different ratings for the inverter. If you're running off the internal battery, it would be 65 watts, which would be 0.54 amps. So while it does say 65 watts, it'd actually be kilovolt amperes, because you got to take into consideration items that have poor power factor. Then there is, if you have this plugged into the 12 volt car adapter, it'll provide a continuous 80 watts, or 0.65 amp. Now there's also 2 USB ports, which are 5 volts DC, of course, and 0.5 amp. So in terms of USB power, this thing sucks badly. Half amp This was great back in the day for charging your flip phone. Yes, flip phone. This came out the year I bought this. The year I think that was the year the iPhone 1 was released, or maybe the year after. So the smartphones hadn't really taken off, and even your Palm Pilots and crap, that really wasn't as power hungry as what we got nowadays. So now that we have that taken care of, let's zoom out again. There's no screw holes on this thing. There's little vents there and vents on the side there. Let's take a look now. This is just a cheapo Harbor Freight meter. This is not going to provide a correct reading. It's not a true RMS meter. But it is showing us 160 something. I wonder if that hit. Oh, I do the backlight. My battery's low on my multimeter. Without the backlight on, we're looking at about 110, 111 volts. Now this isn't a true RMS meter. You'd have to use a much higher quality unit because an inverter, no matter how good it is not going to give you a pure sine wave. It's going to give you a modified sine wave, which the cheap meters have a hard time reading. Now, before I started the video, because there's no screw holes on this thing, this was not designed to be user serviceable in any way, shape, or form. It's glued together. So I went through the seam with the little box cutters, angling it. So I basically did it as if I was opening up a screen on an iPhone without cutting the ribbon cable, which so many people seem to do. So let's just go right at it here. Be real careful. I really should be using a plastic spludger, but I'm too lazy to walk to my office and get it. So I've always wondered what was inside this. The whole reason I was just going to take it apart today so I could replace the cells in it. I got about 2,000 18650 cells in my office. Probably not the best place to store them, you know, in case one, and they're all in the same container, so if one goes into thermal runaway, there goes my house. Oh. Wow, was not expecting that. These are not 18650 cells. Okay. How am I going to do this? This is actually... Here, this will go like this for right now. They used prismatic cells. Yes, flat cells like what you would have in your phone. Which could possibly mean I could use old iPhone batteries as replacements. As I thought, we got 3 cells, one here, and then there's 2 stacked up there to make our 11.1 volts. So yeah, 3 cells. And here I thought they would have had like a row of 18650 cells, but wow, there's your cost right there. Turn that so you guys can see. That's your cost right there. So these are a little bit more expensive than 18650 commodity cells. I even have some Tesla Model S old P85 cells. Those are what I wanted to use to actually replace these with. So you got a little piece of plastic sticking there to keep, if it's got squished, to keep the case from hitting. So what can I disconnect? Okay, I guess we're going to disconnect the battery management board. And holy crap, because I used the razor blade to cut this open. Any deeper, I would have just sliced the side of that battery pouch wide open. Let's see if I can get that. I might have glued that. If you guys see sparks, just so you know, I'm not leaving you here. I'm running outside before this burns my house down. I probably should have discharged it to its shutoff before opening it. Come on, unplug. That is not unplugging. So, we'll just have to make do like this. First, we'll take a look at the rating. And I am very impressed because remember, this is 2007 or 2000. Well, if I bought it in 7, that means it was designed at least in 06. Right here, battery rating is 4,000 milliamp hours or 4 amp hours. The battery is a Yuku brand. So, ain't that funny? This is a Duracell product using a Yuku, Y-O-K-U, not to be confused with Youku, the Chinese YouTube knockoff website. So Duracell didn't even use their own damn batteries in this thing. That is funny. Rated at 4,000 milliamp hours, which would be 4 amp hours at a nominal, and I was right on the money, a nominal voltage of 3.7. Let's let you guys take a little look in there. There. Wow. Ain't that something? Where the heck am I going to get replacements for this? eBay. eBay. Right there. It's inside this heat shrink tubing right there. There's a little inline fuse just in case there's a short on the battery. And then right here you can see this wad of cables coming up right there. That basically goes to the main circuit board on the top here for the battery management system. Make sure all 3 cells are balanced. And, or does it? There's a battery management circuit board down here. And I don't know if you see that little black space right there. There's a resistor. Right there. See that? Right there. Is that a capacitor or is that a resistor? That would be... Oh, it's a resistor. So that would be one resistor. And I see a few more in there. It looks like that one's a little burned, but the thing that still works fine. And then there's 2 thick cables, and let's flip it over and look at the main board here. Let me grab my flashlight. Oh, here, phone light. That's better. There we go. Like I said, I was taking this apart just to fix, replace the cells. I wasn't actually planning on filming this, but what the heck? You guys like interesting stuff. Let's take a look what we got in here. Not super my expertise, but I'll try and explain the best I can. So, okay, we got your USB chargers there. High potted. Let's see. That might be a positive center line. Okay, I'll be quite honest. I have no idea what exactly that one is. Here's the back of the outlet. Now it said floating neutral. There is a ground wire going to the board. What it's grounding to, who knows? Got our fan. Now under high load, that does turn on and spin to help cool this. However, I never actually was able to ever feel any airflow actually coming through there. There is a capacitor right there. Looks a little crusty. That looks like a voltage regulator. I'm not too sure. No idea what these are here. You got a little capacitor right there. Got a bunch of small little caps all over the place. There's a potentiometer, which was potential. The potentiometer is potentially for adjusting the output AC voltage. To be able to adjust it so it's within the right specs. If I wanted to, chances are, if I turn that would probably crank up the AC on this thing pretty high. I might even be able to readjust this to put output 220 or 240, but I don't need that, so I'm not going to. You got a thin film capacitor of some sort. Like I said, I have no idea. You got a toroid, fuse, you got a replaceable micro fuse, at least it would be replaceable, but they soldered it to the board. Larger capacitor there, and a transformer. What is the rating on that? I can barely see it. No, can't. You see this bit of schmutz here, that goo. Inside there is actually a temperature probe, which goes to RT1 there. And that is, my friends, what tells this little fan to turn on. You got some capacitors there, power for the fan. Got another potentiometer right here. And Boshen what? What is that? Boshen what? Electron. Boshen electron, whatever that means. That actually looks like some sort of rectifier. But it's a potentiometer too. There's a little screw on top. Potentiometer there, potentiometer there, potentiometer there. So that's a voltage regulator, definitely for the USB ports. Yep. So this stuff over here is going to regulate the 11.1 volts down to the 5 volts for USB. DC 12 volts. That right there looks like a relay. Caps, there is the charging port there. Wow. XPP 10001744. Big resistor here. Nice big one. I'm not going to look it up now. It'll take too long. If anybody out there in the peanut gallery would like to comment on the values of this resistor, we got a I'm not sure which way you're supposed to read it. You got a looks like a gold, orange, green, purple, or it could be purple, green, orange, gold. Resistor, 2 MOSFETs here. There's 2 more heat shrink there. This is quite impressive what they all managed to fit into such a small space. And that makes sense now why they would use the prismatic cells, the flat cells, instead, or laminated flat cells instead of going with the 18650. Especially if they managed to pack, if they honestly were rated at 4 amp hours, if they managed to pack 4 amp hours into those, that would be impressive. I think the highest capacity cell I have in my arsenal right now, an 18650, would be, I want to say about 2.5 amp hours. I have one that's supposed to be a 5 amp hour, but that one scares me a little bit. It gets a little too hot when I charge, even if I charge at a low rate. So I have that one discharged at the moment. I'm going to recycle that. But realistically, you know what, everybody, here, just sit tight for a moment. Sit tight for a moment. I'm going to go grab an iPhone battery. Yeah, these are big batteries. Okay, I got an iPhone battery here. Bonus points if you can figure out what specific iPhone this came out of. But this is a... Actually, this was a knockoff. That wasn't very good. This one is 1,430 milliamp hours. So, just to show you how much technology has changed and how quickly. Alright, I'll just tell you guys. I'll give you 3 more seconds to post in the description box. Post in the description box what iPhone you think this battery came out of that is, without looking it up, 1.43 amp hour capacity. 3, 2, 1. If you guessed an iPhone 4 and 4S, you would be correct. Actually, iPhone 4S. This one lasted about a week. And now I have, because Gino got my old 4S. So, actually it's considerably thinner and smaller, considerably. And it's not much less than half. 3 of these would equal, let's see, 1, 2, 3. 3 of these would actually equal about 4, we'll say, we'll round it, 4.5 amp hour. And I could definitely fit 3 of these in the space of one of those. I'd be higher capacity. Probably if I got like a 6S or, yeah, I think maybe a 6S cell would fit pretty good there, because I'm not putting lipos in. I got lipos that would fit, but that's too dangerous. The only thing that I'd be concerned about would be the ribbon cable. I think I'd have to end up, it's too thin. I don't know if I would trust a ribbon cable to output up to 60 watts on battery power. That'd be a little scary. So I guess I'll end up discharging this thing and see if I can find the same cells that are in there. I don't want to ruin it. I mean, it works. Just the capacity is just so darn low now. So let's put this back together. And that's it. I just hope you guys enjoyed that. Ow, when did I cut myself? Oh, baby's getting a bath. The baby's getting a bath. There's a little more on the top, but I don't really want to. I don't want to take this thing apart to the point where I might damage it. Like I said, this thing was nice, came in handy. If I can get some new cells in there, I mean, even for like things like camping, this thing was awesome for camping. Have a 120 volt power source whenever I wanted. Toss it in a backpack, bring it down to the beach. Heck, when I was in Vietnam, I brought this with me because where I was going, the power was not good at all. Very unreliable. Come on. Shift it a little bit. Power was unreliable and dirty. Dirty, dirty power. A lot of voltage swing. Frequent outages. So what I did is I kept this thing charged up. I had the power adapter from here, because the power adapter is a switching power adapter. And I had, what if that run my projector? So I had this plugged in to the grid, keeping it charged up. And I used it kind of like a buffer. I would buffer the power through this. So that's switching power adapter. This thing's 60 watt. And I have no idea what that meant. Oh, it's working. It's already giving me a low warning. Overload. That one's overload. So this thing draws 60 watts. It's got a 60 watt worth of LEDs in there. Yeah, it's bright. All right, but it did turn on. And then I would use this then unplugged to charge my laptop, charge my phone, charge my camcorder. I should dig into my old Vietnam trip and pull out some of the video for you guys. Did some neat things there. And so I'd use that as like the middle ground, because then I wouldn't get any fluctuations going. I'd rather have fried this, or even the crappy power adapter it has, than risk frying my laptop or other equipment. So that's it. And no, I don't have a link where you guys could buy something like this. This is no sponsored video. This is something I have now had for about 12 years roughly. So yeah, pretty neat. I suppose if you're camping, you could also use it to run your nightlight. It's got a photocell in there. Come on, photocell, there. Isn't that pretty? That's so pretty. Bye-bye.